In this video, we're going to talk a little bit about solutions. So first, let's start with some properties of solutions. Solutions are always homogeneous mixtures, but they may have a variable composition. That means the ratio of the solute to the solvent could vary. For instance, I could have a salt water solution that was 1 gram of salt in 100 milliliters of water, or a salt solution that's 10 grams of salt in 100 grams of water. The solute should remain uniformly distributed. It does not settle to the bottom. Okay? And we can generally separate the solute from the solvent by some sort of physical means, often evaporation. So the solute is the thing that gets dissolved into the solvent. The solvent dissolves the solute. So a couple terms that we might want to be familiar with: soluble and insoluble. Things that are soluble in each other dissolve in each other. Insoluble means they do not dissolve in each other. And then we use the word miscible and immiscible if we're talking about two liquids. So we might say that oil and water are immiscible, or alcohol and water are miscible. So here's some examples of solutions. You might always think of solutions as a solid in water, but so solid in a liquid, something like tea or salt water. You can also have solutions which are liquid in liquid. If you go to the gas pump, you'll see that the gasoline, there's different kinds. It just has to do with the percentage of octane mixed up with other alkanes, or alcohol and water. When you deal with liquids and liquids, which one's the solute? Convention generally says that whichever you have less of, you call the solute. It doesn't really matter. A gas in a liquid, something like seltzer water. You can also have a mixture of a gas and a gas, like air or natural gas. Solid in a gas, you could have hydrogen in palladium. It's a way of storing hydrogen. And then solid and solid, you may have seen if you go to the dentist. So mercury and silver or gold, it's called an amalgam. It's a homogeneous mixture, and it's used in dentistry. Couple terms: dilute versus concentrated. These are relative terms. Okay, there's no sort of set barrier that you have to cross to go from dilute to concentrated. If we have 3 solutions here, and solution A has 3 particles dissolved, and B has 5, and C has a whole bunch, we say that A, if I were comparing A and B, I would say A is dilute and B is concentrated. But if I were comparing B and C, I would say B is dilute and C is concentrated. Or I might just say B is more concentrated than A, and C is more concentrated than A and B. Or C is the most concentrated solution there, or A is the most dilute solution there. So it's all relative. You're just comparing one thing to another. So you're going to hear us use 2 different terms: solubility and concentration. Solubility is kind of a theoretical thing. It's the amount of solute that you can theoretically dissolve in a given amount of solvent at a particular temperature. Concentration, on the other hand, is the amount of solute that actually have been dissolved in a given amount of solute at a particular temperature. For the rest of this video, we're going to be talking about solubility. We'll look at concentration units in a different video. So when we talk about solubility, we'll use terms saturated, unsaturated, and supersaturated. Saturated means that no more solute could be dissolved. So I've dissolved as much solute as that is theoretically possible in a given amount of solvent at that temperature. If it's unsaturated, it just means I could dissolve more solute. If it's supersaturated, it means more solute has been dissolved than is theoretically possible. Okay, which is a little weird. So for instance, if the solubility of sugar in water at 20 degrees is 204 grams of sugar in 100 milliliters of water, let's say I have 100 grams of sugar in 100 milliliters of water. Well, this 100 grams is less than 204, so this solution is unsaturated. Okay? If I have exactly 204 in 100 milliliters of water, we say that this solution is saturated. And I'll usually abbreviate like that. If I have, say, 250 grams of sugar in 100 milliliters of water, This is supersaturated. So how do we get more solute dissolved than is theoretically possible? So supersaturated solutions, for instance, if you look at sodium acetate, the solubility of sodium acetate, and solubilities are often given in grams per 100 grams of water or 100 milliliters of water. Same thing, right? So let's say the solubility at whatever temperature I'm at, let's say like 20 degrees, is 123 grams in 100 milliliters of water. So let's say I'm at 20 degrees and I decide to throw 200 grams of sodium acetate into a beaker. I'm going to find that some of it dissolves, but a whole bunch of it is just sitting here at the bottom because it's exceeded its ability to dissolve. But what happens if I heat it up? Well, most solids become more soluble when they're hotter. So let's see, we heat it up and we get all of the sodium acetate to dissolve. Okay? So here it was saturated with a bunch of stuff at the bottom. Here we're probably still saturated, right? We heated it up until it all just dissolved. Now the trick is, can I cool it down really slowly and carefully without jarring it or upsetting it? You have to talk nicely to it. Oftentimes you can get all that kind of extra sodium acetate that you dissolved, you can get it to stay dissolved. So now you're returning it to 20 degrees Celsius, but it stays dissolved, so it's supersaturated. So if we look at an example here, let's say I'm trying to dissolve 100 grams of some solid. I throw it in at 25 degrees Celsius, and we'll say that 5 grams is dissolved. Okay? But 95 grams is still sitting on the bottom. So I heat it up, or I stir it, right? So I stir it and I get 91 grams to dissolve because that's its solubility at 25 degrees Celsius. Okay, so here it was unsaturated and I kind of stirred it or let it dissolve for a while and I got it to saturate it at room temperature, say. So then what I'm going to do is I'm going to heat it up and I'm going to get all of it to dissolve. Okay, so now it's all dissolved here. So now it's unsaturated. Okay, because I probably could get more to dissolve if I wanted to. And then I cool it down slowly and it stays dissolved. Okay, so if no precipitate forms, I've got a supersaturated solution. If precipitate does form, then it simply goes back to saturated. So it all depends on whether or not it stays dissolved or it precipitates. Some solids are simply better at staying dissolved than others. Sodium acetate's a particularly good one, and that's usually what people will play around with in the lab. And then one last kind of cool thing, let's say if I have an unsaturated solution, what happens if I add a crystal of the solute to that unsaturated solution? That crystal will dissolve, right? Because it doesn't have as much solute dissolved as it can handle. If I add it to a saturated solution, it just sinks to the bottom because it's already full, right? It's saturated. It has as much dissolved as it can hold, so that extra little crystal just floats to the bottom. Well, sinks to the bottom. If it's a supersaturated solution, though, it's really pretty cool. Supersaturated solutions are they're just very unstable, right? Because we've shoved a whole bunch of extra solid in there that's not supposed to be able to dissolve. So if I add just one little crystal, what happens is all of that extra, okay, not all the solvent or solute, but all that extra solute that starts to crystallize out, and it looks really pretty while it does it. So it will sort of the extra solute, the extra solute precipitates. And it looks pretty cool. So that's our kind of introduction to solutions and some of the terms that you should be familiar with.